Hello, AP Calc students. This is our volumes day 2 video. And I'm going to kind of assume that you know the stuff we did on day 1, like how to find the volume of a solid of revolution if it's rotated around an axis. And we'll see in these that if the axis of rotation, the axis around which you're revolving it, is one of the edges of the region, then you're going to have disks. And if the axis of rotation is not the same, is not one of the edges of the region, then you're going to have washers. And remember, a disk is just like a circle, basically, and a washer is like a circle with a circular hole in the middle of it. So this is your typical kind of washer problem here. So you have this curve y equals 2x squared, which we know is like some kind of a parabola like this. And you have this line y equals 4x, which is a straight line. Looks something like this. And it says to revolve it around the x-axis. So we're going to kind of spin it like this. We're going to spin it around like this way. And while you could like think a whole lot about like the circles and stuff, there's like kind of a more general way to do this, where we say the volume of this thing is pi times the integral from a to b of like the outer radius squared minus the inner radius squared dx. And for these, it's always just a question of figuring out what is big R and what is little r. So I'm going to draw this picture again with slightly thinner lines so I can get a little better detail on it. So it'll be like, the region will look something like this. And this is the axis of rotation right here. So like this distance here is one of the r's, and this distance here is the other one. This one is big R of x, and this one is little r of x. And like we saw with areas and with volumes of no cross section and everything, the way we figure out these distances in the coordinate plane, the distance between two curves, I guess is a better way to say it, is to do the top curve minus the bottom curve. So for big R of x, well, for any r, I'll just say any distance in a coordinate plane, it's going to be top minus bottom. And that's true as long as we're thinking about the vertical distance. If we're talking about horizontal distance, we're going to do right minus left. We'll get to those in a minute. Vertical distance is top minus bottom. So for these vertical distances, the top curve here is the straight line, so it's 4x. And then the bottom curve is the x-axis, which is y equals 0, remember? So it's 4x minus 0, so it's just 4x. And little r, similarly, we do the top minus the bottom. Since r of x is the parabola one, sorry, since this curve is a parabola, that's going to be 2x squared minus, again, 0, because I'm revolving it around the line y equals 0. So here's my big R, here's my little r. Then we can just plug everything in. Big R was 4x. Little r was 2x squared dx. And now the only thing missing is my a and my b. I'm pretty sure that a is 0. I just don't know what b is. So to figure out the intersection points, we know to set these things equal to each other. So 2x squared equals 4x. Subtract 4x from both sides. 2x squared minus 4x is 0. Factor out a 2x. I get x minus 2. So x is indeed 0, and the other side is 2. So from 0 to 2. And that is my integral. That is the worst 2 I've ever drawn, probably. So let's try that again. 2 to 0. And now I'll probably square these things, and then I'll integrate. From 0 to 2, 4x quantity squared is 16x squared. 2x squared quantity squared is 4x to the 4th dx. Now I integrate 16 thirds x cubed 4 fifths x to the 5th from 2 to 0. which is, the 0 is just going to give me zeros. So I got pi times, let's see, 2 to the third is 8. 8 times 16 is 128. Yeah, 128 over 3 minus 2 to the fifth is 32. That's another 128. I wrote equals. Minus 128 over 5. And that's a fraction, which you could figure out in your calculator, or you could just leave an answer like this if you wanted to. But that's the basic rule there. It's big R, pi times the integral from a to b of big R squared minus little r squared. And you figure out the r's by doing top minus bottom. I just tried to do that fraction in my calculator, or in the calculator online, and I can't make it into a fraction here. Or maybe there's a way to do it, but I don't know what it is. We do it as a fraction, we get, I don't have my calculator right next to me, but that's fine. This is how you do it. I'll let you all figure out what that number is. I don't want to do both of these things times to fit the 15. This gets going to be a pain in the butt, but basically here is our kind of our general formula for these volumes. This works if there's a hole in it. It works if there's not a hole in it. Basically what I was trying to say before about the edge of the region being one of the limits. Like if I'm talking about one of these volumes and it's like, just like whatever, like maybe it's like x squared. And I'm talking about this area. I want to revolve this area around the x-axis. Like the little r is 0. Like there's no little r because y equals 0 is the edge of the region and it is also the axis of rotation. So if the edge of the region is the axis of rotation, then little r of x is equal to 0. And that gives us what we call disks instead of washers, meaning that there's no hole in it because this is there's no space for a little r to exist. If the edge of the region is not the axis of rotation, then you're going to get a washer. So here's another example. This is one where we're rotating this little region here between these two curves, 4 minus x squared and x squared plus 2. We're spinning this around the line y equals -3. So again, I think it would be helpful if you guys could think about this, I think, as this kind of a formula. Every time it's just going to make you're not going to have to be remembering like, oh, was this a washer? Is this a disk? It's like, how do I find these distances? It's always like this. And remembering that our vertical distances, which are the r's, are equal to top minus bottom. So the key here is figure out A and B, and then figure out big R and little r, and then plug everything in. So big R of x, looking at my picture, this is the axis of rotation down here. So I think about the way this looks, the outer radius is this long line here. That's a terrible straight line. The outer axis, the larger axis of rotation is a line that looks like that. And make it a little bit longer so it actually gets down to the line. Maybe make it dotted just for a giggle. So this is big R right here, and little r is the inner radius. So it's going to be like that somewhat shorter line right there. So I could say maybe this is big R right here. And it's going to be equal to the top curve minus the bottom curve. So the top curve is 4 minus x squared. And the bottom curve is y equals -3. So it's minus -3, which is really +3. So I would call that 7 minus x squared. And little r is this guy right here. And here, the top of little r, the top edge of it is x squared plus 2. And the bottom of little r is this line, y equals -3. So I do minus -3, which is again a plus 3. So little r is x squared plus 5. And now I'll set up my integral and then I'll find the limits. Big R squared minus little r squared dx. And let's see, the limits, I got to set 4 minus x squared equal to x squared plus 2. So if I do some math here, I get 2x squared equals 2, which means x squared is 1, which means x is positive and -1. So I'm going to do, am I going to do this one? I'll do this and then I'll stop and I'll do the next couple in the next video. So this is just going to be kind of like a lot of algebra we have to do here, because if I'm going to take this integral, I'm going to have to square these things. So if I square this first one, I get 49 minus 14x squared plus x to the 4th minus, if I square this one, I get x to the 4th. That's kind of nice. Plus 10x squared plus 25 dx, which is pi times integral from -1 to 1. See, 49 minus 25 is 24. That makes sense? Yeah, it's 24. I'm taking care of those two numbers. Negative 14x squared minus 10x squared is negative 24x squared. And x to the 4 minus the 4th is 0. That's convenient. So it's just this now. So it's pi times the antiderivative of 24 is 24x. The antiderivative of this is 8x cubed, running from 1 to -1. So it's pi times, let's see, 24 minus 8 is the first one. When I plug in 1 for x, -1 for x, I get negative 24 plus 8. Yeah. So it's 24 plus 24 and then 8 negative. So it's 48 minus 16, which is 32. So 32 pi. That's the volume of this quote unquote wedding band. Is that what it looks like? Maybe, kind of. I don't think wedding bands actually look like that. I think they're flat on the inside, but it's kind of vaguely what that shape is. So these two examples kind of gave us the whole top minus bottom for the distances, and big R squared minus little r squared for any kind of really any kind of volume of revolution. But it makes more sense to think about disks when they're disks and washers when they're washers, but you can always use this formula as long as you understand that for a disk, little r is going to be equal to 0. So that is how we find volumes of revolution. Stay tuned for the next one.